Alright guys, I'm going to show you how to solve simultaneous equations. Now, what does that mean? So first of all, have a think, what does simultaneous mean? It means at the same time. So we're basically trying to find we're trying to find a pair of numbers that satisfy both of these equations. Now in previous videos when we've obviously graphed this as a straight line because there's obviously infinite number of solutions to this equation. Same thing for this one. There's an infinite number of solutions to this line. But there is only one solution that satisfies both of those equations, and that's what we're going to be trying to figure out. So the only process we really have for this right now is we graph both of these. So we've got 3x plus 1, so that's going through 1, and it's got a gradient of 3, up 3 and across 1. So this one looks something just want to get this right. Oh, it's going through 1, sorry. Something like this. That's y equals 3x plus 1. And this other equation goes through positive 6 and has a gradient of negative 2. So we can see here that that is the point of intersection. Now this is obviously a nice easy example. We can see that it's across 1 and it's up 4. So with going 1, 4 is the x, y ordinates that satisfy both those equations. But we want a process where we can solve this without having to graph it every time. Okay, well, what do we want to know where these lines are the same, so we could make them equal each other. Y equals y might be a good start. We want to find the y's that satisfy this equation. Well, there's infinite y's, so that's not very helpful. However, we can make 3x plus 1 equal negative 2x plus 6, because that's where they would be the same. So 3x plus 1 equals negative 2x plus 6. Where are they the same? Well, we've solved linear equations in the past. We're going to add 2x to both sides. That'll get rid of that. And we're going to subtract 1 off both sides. So we get 5x equals 5. Then we can divide both sides by 5. So that x equals 1, which is what we've got. So we've found that the x value of 1 will satisfy both these equations, but we need to find the y value. Well, what we do there is all we have to do is we have to take this x equals 1 and sub it back into either of those equations, because both of those equations go through that point. So it's up to you really, whatever one you're more comfortable with. I'm going to put into this one because it's positives only. So 3 times 1 is 3, plus 1 is 4. So then we write y equals 4. And as a coordinate, we write it as 1, 4. And we can see how that is the point of intersection, or the solution of that simultaneous equation. Now these go up to 3 variables, 3 equations, 4 variables, 4 equations, 10 variables, 10 equations. It's actually a massive part of mathematics at higher level, is solving simultaneous equations. And if we get really good, we'll do some linear, non-linear simultaneous equations later on. So that is called solving simultaneous equations by substitution. We look at a variable in one equation and we replace it with what that variable is equal to from a previous equation. I'll do another example and show you what I mean. Let's have a look at this one. We have x plus 2y equals 6. So by intercept method, we know that x is 6. And we know that y is 3. So we know that our equation of our line is looking like this. That's our first equation. And we've got negative x plus 2, so it's up 2. And it's going down. Yeah, it's going down. Sorry, at a gradient of -1. Okay, so it looks like our solution should be at -2, 4. Okay, but how can we, instead of having a graph, instead of having to draw that up on a grid paper, how can we do that just algebraically? So what can we replace? Well, we've got y equals -x plus 2, and we could replace that y with that entire relationship. So we have x plus 2 times y, but y is -x plus 2. Awesome. Now it's just one equation with one variable. So theoretically, we should be able to solve this. Okay, we're going to have to expand. So x, and then we've got plus 2 times -x, so minus 2x. Plus 2 times plus 2 is 4. Collect your like terms. -x plus 4 is 6. Might just subtract that 4. -x is 2. And because we've got a negative on both sides, we'll times both sides by -1. X is in fact -2. Okay, well if x is -2, we need to still find this corresponding y value. We think it's 4 by looking at this graph, but later on at higher level linear equations, those points aren't going to be as obvious, especially if you've graphed them kind of averagely, like I have. Okay, we need the y. We just have to take this value of x, -2, and plug it back into either of those equations. They're both fine. I'm just going to put it into this one. Now I've got -x, and x is a -2. So -2 is +2, plus 2 is equal to y. So y is 4. So we're right. -2, 4 is the solution. So this is two types of substitution. The first one was they're both equal to y, so make them equal each other. So we substitute in 3x plus 1 for y and solve. The other one, we have x plus 2y, so intercept form, and gradient intercept form. Well, this y equals -x plus 2 could be substituted in for the y in that first equation. Cool. Hope that makes sense.